In 1856, American scientist Eunice Foote took some cylinders full of different gases and placed them outside on a sunny day. She noticed that some of the cylinders heated up more than others, but the one that heated up the most was full of carbon dioxide. Not only that, but it remained warm long after she took it out of the sun. She had discovered the greenhouse effect. Noticing this, she postulated that Earth could also be experiencing the same kind of effect because its atmosphere is rich with carbon dioxide. And she was right. Climate change is the change in temperature and weather over time. For most of history, it's been completely naturally occurring, but since around the 1800s, human activities have sped up its effect on the planet. But what does it mean for us? How do we know it's even real in the first place? And is it even really such a bad thing? You've probably heard of the greenhouse effect and greenhouse gases before, but despite what some sources may lead you to believe, both are absolutely necessary for all life on Earth to occur. Essentially, light energy from the sun radiates down to Earth, and that energy is absorbed by the Earth's surface. But it doesn't just disappear. Instead, it gets re-emitted back out into the atmosphere and is sort of trapped by the layer of greenhouse gases such as carbon dioxide or methane. As a result, Earth sits at a pretty comfortable average temperature of 59 degrees Fahrenheit. But you could imagine what doubling or even tripling the number of greenhouse gases in the atmosphere would do to the temperature. If some humans were to, say, burn fossil fuels to generate electricity, that would release CO2 into the atmosphere. On smaller scales, this is almost negligible, but on the scale of global industrialization, not so much. This is a graph from NASA's official website. I highly recommend you go check it out for yourself because it is jam-packed with useful information on climate change. For hundreds of thousands of years, the ratio of CO2 particles in the air hasn't been above about 300 parts per million, but in the last 100 years, it's soared to 420. This may not sound like a huge deal, but George Zaden provides a really great analogy for what this means for the US alone. Imagine a Hiroshima-sized nuclear bomb going off over the US every 3 seconds. That is the sheer amount of energy being converted into heat as a result of these particles. We've also noticed that Arctic sea ice has been receding, and at rates that can't be explained without this rapid climate change. Because the average temperature of the Earth has been steadily increasing, more surface ice is melted annually and disallows new ice to form fast enough. This animation shows its effects since 1979. If you're still not convinced that climate change is happening here on Earth, then just look at other planets, like Venus. I recently read Neil deGrasse Tyson and Lyndsey Walker's To Infinity and Beyond, and they explain that Venus has scorching temperatures not because it is closer to the sun, but because it houses 90 times more carbon dioxide. The story goes that water vapor, which is a greenhouse gas and the most abundant one here on Earth, caused temperatures to rise due to the greenhouse effect. And this rise in temperature caused water vapor to evaporate from the oceans, which increased temperatures, which caused more water vapor to rise, which increased temperatures, and so on and so forth, until you have the volcanic hellscape of Venus today. American astronomer Carl Sagan realized this back in 1985, and he went before Congress to testify, saying that if we did nothing, Earth would be next in line. And he was right. Today, we see that ocean levels are rising. Nearly 40% of all people who live in the US live in coastal regions, and experts say that by 2050, many homes will be inundated or even totally submerged with water. Oceans are also becoming more acidic, literally. Because carbon dioxide in the atmosphere eventually finds its way down into the oceans, it causes pH levels to drop, and this can be detrimental to many forms of marine life, most notably coral reefs. And even the weather has grown erratic. Higher temperature differentials in the atmosphere provide the right conditions for longer, stronger, and more frequent hurricanes. It seems as though humans have stirred up trouble for Earth. What can we do to make it up? Well, there are a few solutions at play right now. Many governments have posed a carbon tax in which big corporations will have to pay up for their pollution. And this is a good idea. 29 countries right now have adopted this, most of which are in the EU, but economists agree that none are quite high enough yet to drive significant change. Alternative energy sources like nuclear power and renewable resources have also been proposed as strong ways to reduce emissions. But transitions to these sources have been slow. So slow that they will not be meeting our needs fast enough. It's daunting, thinking that the future of our planet rests in the hands of a few powerful individuals. I mean, it's a very real fact that most carbon emissions are determined by a small fraction of the population. What are we, the rest of us, supposed to do about that? Well, you make sure the powerful individuals are the right individuals. Vote for the officials who respect the science and its implications and hold those who don't accountable. Getting the right people to flip the right levers isn't impossible, but there is something bigger you can do. Vanessa Bohns makes a really great point in her book, You Have More Influence Than You Think. If you buy an electric car or eat less meat, you won't save the world. You won't even really make a dent. But if you do those things, you will have modeled the behavior that you believe is normal. Now, it's not guaranteed, but other people may also catch on, and they themselves might go out and buy a solar panel or turn their lights off more often, and they too may cause other people to bandwagon. After enough time, many people are involved. There would be no need for reform because it will just be the status quo. Change isn't easy, even if I've made it seem like so, but it isn't hopelessly impossible either. The best thing you can do right now is to play your part. Stay safe. The exact science of anthropogenic climate change is dense, more dense than this or any single video could cover, so if you want to learn more about it for yourself, there are links in the description. Education is one of the surest ways to drive change. Furthermore, keeping an open mind and remaining healthfully skeptical will guide you through that vast sea of information. Thank you for your time.